Okay, so for the first one, what do we do?
Okay.
8 times 2x is 16x. 8 times negative 7, negative 56 equals 26. And then add 50, this should be 24, not 26. Add 56, makes that 80. 16x equals 80. And then divide by 16, x equals 5 is correct. How about over here? Yep, we see the parentheses, so we know we got to start there. 5 times 3x, 15x. 5 times 1 is 5. What's next? 15x and 2x makes 17x plus 5 equals 56. And then subtract 5. 17x equals 51. Divide by 17. X equals 3. Questions so far? Number 3, where do I start? Okay, so the 8x doesn't change. We've got negative 1 times 5x. Negative 5x. Negative 1 times negative 1. Positive 1. And that equals 24. And then negative 24. Thank you. And then well, you got 8x and a negative 5x make 3x. Okay. Equals negative 24. And then subtract 1. 3x equals negative 25. Divide by 3. X equals negative 8 1/3. Questions there? Okay. Number 4. We've got more than one set of parentheses here. So we're going to start on the left side and reduce what we can. Then we'll go to the right side, and then we'll solve from there. So on the left side, we have to multiply by the 7. 7 times 2x, 14x. 7 times 5, positive 35. What else can we combine there? 14 and negative 4x make 10x plus 35. On the other side, we got parentheses there too. So we'll start with those. 5 times 6x, 30x. 5 times negative 3, negative 15, and the positive 4. So what can we combine there yet? Okay, so the 30x won't change. Negative 15 and positive 4 makes negative 11. And then, so we get rid of the smaller of the x's, the 10x. So 35 equals, yep, 20x minus 11. And then, can I get rid of the negative 11 by adding 11? 46 equals 20x. And then, divide by 20 because it's 2.3 equals x. Or 2 3/10 if you want to leave it as a fraction. Questions there? Well, let's look at a couple that we haven't seen yet. Like this. What was done to x when they built this equation? It was square root. What's the opposite of a square root? power of 2 squared. So the square root and squared cancel out, leaving us with x. What's 7 squared? 49. Very good. Somewhat more complicated is this one. X squared equals 25. Now it looks like it's just the reverse of the one we did, sort of. And it kind of is. What's the opposite of squaring something? Square rooting it, right? So x squareds and the square root cancel out, give me just x. The problem is over here. What's the square root of 25? 5 or negative 5. Negative 5 squared would also equal 25. Exactly. Negative times negative is a positive. So there's two possible answers there. If you just gave one of them on a quiz, I'd be okay with it. How about this? Yep. X to the third power equals 27. Third root. Cancels that out. What's the third root of 27? 3. Very good. 3 to the third power equals 27. How about that one? Yep. So we have to do a sixth root. Yep. So the sixth root and the sixth power cancel out, gives us x equals. Anybody know the sixth root of 15,625? 5. Can't be 8 because 8 to any power would have to be an even number. On your calculators, can you guys get that to work out? So you gotta do 5, then the x root, or sorry, 6, then the x root. 15,625. Yeah.
My calculator, you got to hit stack and then.
Yep, the root key. Here, I'll come take a look at it for you. Well, the good news is I think we are ready for the quiz. So, yeah. So we have looked at some equations that look like this. 3x plus 7 equals 43. And how did we go about solving that equation for x? What did we do first? Subtract 7. So we get that 3x equals 36. And then our last step is to divide by 3. Good. So we get x equals 12. But what we're going to look at today is what happens if, instead of having numbers in there, bless you, instead of having numbers in there, we have other variables, like ax plus b equals c. Now, first of all, we would have to be told what we're solving this for because there's technically 4 variables there. So let's say I tell you that we're going to solve this for x. This is exactly like this problem over here. We just have to work with the variables. So first thing we have to do, just like we subtracted the 7 over here, we have to subtract b over here. Takes that b away, leaving us with ax. Now the difference though is here, we could take 43 minus 7 and combine them to get 36. Over here, c minus b has to stay as c minus b. Our next step over here, it was to divide by the 3 to get rid of the 3. Same thing here. We're going to get rid of the a by dividing by a. That leaves us with x. Over here, C minus B divided by A, we just leave it in fraction form as C minus B over A. And that's it. If you think about it, if I'm solving this equation over here, what I did was I did 43 minus 7 and then divided by 3. This is just giving me those steps if I want to solve this equation. You do C minus B and then divide that result by A. What it's for is if we have a formula that we're going to be using over and over again and putting different numbers in. You know, for example, for a taper, your taper formula is D minus little d over L divided by 12, right? Well, let's say that we're going to be doing a lot of things where we're going to be trying to find the smaller diameter. Actually, you know what? Let's say this. Let's say we're going to try to find the large diameter given a certain taper, a small diameter, and a length. So we're going to solve this for capital D, big D. If we look what was done to big D here, well, because of the fraction bar, the first thing that had to happen when this was being put together was you had to subtract little d. Then it had to be divided by L over 12. So to solve this, we have to reverse that process. What's the opposite of dividing by L over 12? Multiplying by L over 12. That's going to cancel that out, right? So I'm going to multiply over here by L over 12. Well, T times L over 12, you think of it as T over 1 times L over 12, that's going to be TL over 12. Does that make sense? So now then our last step in solving this for big D, after you get rid of little d was subtracted, so we got to add little d. So that's gone there. We've got capital D here. This is T times L over 12 plus little d. So now if we are given the taper is 0.2 inches per foot, the length is 20 inches, and little d is 2.4 inches. We can find big D by just substituting those values in. So T is 0.2, L is 20, little d is 2.4. 0.2 times 20 is 4, right? Over 12. 4 over 12 is 1/3 plus 2.4. 1/3 plus 2.4 is 2.73333. So big D is 2.7333. Or if you wanted to, you could look at it as 20. Oh, what's it? 20ths. So you'd have 8 20ths. Nope, it'd have to be 30ths. What was that? 4/10 would become 12 30ths plus 10, so 22 30ths. Does that look right?
As long as I can write it down.
Sure. Okay, so come here. This thing just like chews up the batteries. It's weird. No, that's just put. It takes not triple A's but quadruple A's. So it's you have to special order them. Yeah, for a set of 4 of them, it's like $13, $14. Yeah, no reason why I couldn't just plug into the thing and dock or something and charge or. Yep. So let's try one. Power is equal to current squared times resistance, and we're going to solve this for I. If we look at this, what has been done to I? So we're looking at the side with the I. I has been squared, definitely. And then times resistance. So to take it apart, we're going to divide by resistance. Remember, we got to go backwards. Take off the last piece first. Divide by the resistance. So P divided by R equals I squared. And the last step is to square root it. Make sure you put the square root over the whole thing. Square root of P over R. The square root and the squared cancel out. That's just I. Now again, this is beneficial if you're going to take one measurement of power and one measurement of resistance and try to find I, you're better off just putting the numbers in this formula and solving it. But if you're going to have to take several measurements and calculate the current from them, then you'd want to solve it like this so you can just plug in the numbers and calculate it and not have to solve an equation. Oh, they're all over the place though. I mean, that taper formula is one that you guys would have to use. In your big book, we're going to have you guys look at page 392 through 394. It's exercise 15-4.